righty. Is this one for me or you? What do you think?
This one looks like it's for me. It looks like a geometry question.
All right.
So this is saying a suitcase measures 24 inches long and 18 inches high. What is the diagonal length of the suitcase to the nearest tenth of a foot? So I'll draw a picture of a suitcase, my red suitcase. So we said it's 24 inches long and 18 inches, oh, that's not a very good suitcase, but 24 inches long and what did I say, 18 inches?
Yeah, I think so.
High? Yeah. And 18 inches high, and then I'll just put a little handle up here. Okay. So we want to know the length of diagonal, and when would this be useful? Well, if you were trying to fit something inside of here, it might be useful to know, I don't know, something long and narrow.
This is the longest thing I can fit in this suitcase.
Absolute longest thing you could fit in there, not accounting for the three-dimensional, but just kind of flat in there. So we have a suitcase. Most suitcases are rectangular, and I think this said it was rectangular. So really what we have here is a kind of right triangle. Let me fix that a little bit. And because it's rectangular, we know these sides are all the same. So really what we're doing is we're trying to solve for this diagonal. I'll call it D. With a right triangle, we're going to think about Pythagorean theorem. If you remember, Pythagorean theorem is this relationship between all the sides of a triangle that says the legs squared, so this 24 inches and the 18 inches, the sum of the legs squared, so a squared plus b squared, is going to equal the hypotenuse squared. An application of this, we could say that if you wanted to call this A and you wanted to call this B, we would say 24 squared plus 18 squared equals, and in this case, our hypotenuse is c squared, because we're talking about a diagonal and I named it D, we could say d squared. So in order to solve this, like you would solve every other equation, the easiest first step is to just go ahead and simplify everything on each side. So 24 squared is 576. 18 squared is, what, 260, 324. And that equals d squared. And again, we continue to simplify this. So 576 plus 324 is 900. That equals d squared. And this is one of the things where I notice some students get hung up if we haven't seen this in a little while. We're saying d squared is 900, but you know the diagonal of this suitcase is not 900 inches up. First of all, that wouldn't make any sense. But what we have here is d squared. We're solving for d. So we need to think about what the inverse of squaring something is. In this case, it is the square root. So the square root of d squared, because it's the inverse, is going to basically cancel out that squared operation. And of course, we need to do the same thing to both sides. So d equals, and this is something I always mention to my students because I don't want them to get held up when they get to advanced algebra.
Oh, thanks.
I always mention this. Mathematically, in this case, d equals a positive or negative 30. So in the context of this problem, yes, this works mathematically, but in this case, we're talking about the diagonal of a suitcase, and it makes no sense for a diagonal to be a negative length. So in geometry, a lot of times when we talk about these triangles, we ignore that negative, but that doesn't mean that algebraically it wouldn't be included, because when you get to more advanced mathematics, that negative is important. So I like to get students thinking about that there are two solutions, but in this case, because of the problem itself, there's only one, and it would be 30 inches. Another way to kind of quickly think about this is the hypotenuse is always going to be the longest length because it's across in this right angle. So if you ever get anything smaller for the hypotenuse than any of the other legs, then you made a mistake. So hopefully that helps.
No, that's great. That was a great question, too.
Yeah.
And Pythagorean theorem is everywhere.
Everywhere, yeah.
In math in high school.
Yeah, this is such an important theorem because we see right angles, which you can create right triangles from that. You can get a lot of information out of that.
It seems like a real world one too. I mean,
yeah.
It's so often that you can use that to figure out some piece of information that you could really use.
Subscribe! Come on, push the button.
You know you want to.
Do it.